So right now you might notice I'm underground, and that is because I'm trying to catch bugs from my game. I'm not underground. This is a green screen. As you can see, I got myself a really nice green screen. Right, so today I'm bringing you 5 awesome programmer game development tips for you can use in your game. Some of this you're gonna know, some of them you're not gonna know, and I guarantee you get smart. You're gonna be smarter. The first concept I'm gonna talk about is called object pooling. What it means is when you actually delete an item, when you delete an object in your game, it's not actually deleted, but the copy is kept back there. So let me give you a practical example. You are fighting enemies. It's a shooter game. It's a, let's say, maybe a Diablo type of game. There's lots of enemies, and you keep killing enemies over enemies. Now, for the game, for the computer, it might be more expensive to just create a zombie again and again and again and again. You know, create 100 zombies. But what you can do is when the player kills a zombie, you just hide that zombie, and whenever another zombie is supposed to appear, you just take the hidden zombie, put it where the new zombie is supposed to be, and that's it. That's object pooling. You're not really gonna see an effect in the gameplay unless the game is really heavy, but it's something you might want to consider for optimizing the game, how fast the game is. If you're using any actual real game engine, you should probably not worry about this, because from what I know, game engines actually do this on their own. It's I don't know, if you're making your own game engine, maybe you should think about it. I don't know. The second tip has to do with how you make rain in your game. Right, it's obvious. Like when you're in a game, it's not actually raining in the whole world of the game, because that would be London. No, it's actually, you usually have a cube around you in which it's raining. It's not raining behind you. It's never raining behind you. It's never raining too far in front of you or in any direction. The rain actually follows you, and that's how it works. There's a cube of rain around the main character, right? Around the camera even, maybe. And yeah. This, of course, I'm talking about 3D games, but if you have rain in 2D games, you can apply this as well. You can only have rain where the camera is, where the screen is. Keep that in mind, you never know when you're gonna need to rain a little bit more. Let me talk to you about the biggest sin of game dev. Then I'm gonna talk to you about the biggest cost of game dev. I'm gonna show myself out for this joke. Now, this has to do with diagonal movement in a game. Now, I've made like 2 more videos about this, but no one watched those, so I'm just gonna say it again. You think about this, let's just do the math in your head. Like, if you move 1 meter up and you move 1 meter to the left, how much you're gonna move diagonally? It's not 1 meter, let me tell you that. It's close to 1.4 meters. What that means is diagonal movement in games might be faster than normal movement. And if you're developing a game in which you have movement in 2 directions, you might want to consider that moving diagonally might be faster than moving up and left and down and right. Now, I'm not saying this is necessarily a bad thing, it's just something you should be aware of. Now, if your diagonal movement is faster than normal movement on purpose, well, that's perfectly fine. But if you do this by mistake, you might want to check it out. You might get some behavior you did not want. Food for thought. Last, 4th tip. Before I get into it, please do consider hitting the like button, hitting the subscribe button, and doing that, you know, I don't know, follow me on Twitter maybe. I'm sure you can come up with a way to support me. My 4th tip is how Minecraft renders cubes. Now, you've played Minecraft. I know you've played Minecraft. I know you know Minecraft. It's a game with cubes. There's a lot of cubes. Now, when you're playing Minecraft, you can imagine your house is made of hundreds and hundreds of cubes. Obviously, if the whole world is made of millions over millions of cubes, your GPU is gonna catch on fire. So obviously, not every cube in the game is rendered. But you might have wondered how it's done. Well, let me tell you. Minecraft has these things called chunks. It is not a big deal. It's just every chunk is basically a group of, I believe, 16 by 16 by 16 blocks. cubes. And the cool thing is, every chunk is actually not made of multiple cubes, it's actually one single object that looks like it's made of cubes. Mind blown? Let me explain. So whenever you put on a cube in a Minecraft chunk, the game takes those coordinates and re-renders the Minecraft chunk so that it appears like there's another cube there. Yes, in that situation, the game redraws the texture of the chunk object. It remakes the 3D model of the chunk. The 3D model is just gonna look like there's another cube there, right? Also the texture, same with the texture, it remakes the texture so that it appears like it sticks some texture onto the new part of the object. So inside a chunk there's actually nothing. There's nothing visual, there's no 3D thing, no texture inside the chunk object because there's no cube there, it's empty inside. Obviously, in the background, in the memory of the game, every chunk remembers what blocks, what cubes it has inside, but it does not render them. It just remembers them inside programming like Java arrays. That. Like the video. Subscribe for more Minecraft tips and useless game tips you're never gonna use in your whole life because you're a web developer, and yeah. See you later. But follow me on Twitter first, then see you later. Bye.